This video is on Unit 12, Lessons 1 and 2, which is the start of our probability unit. So before we begin, you may want to recall that when you are finding the probability of something occurring, you are giving me an answer of a number that is between 0 and 1. If you get a probability of 0, that means it is never going to happen. If I said there is a 0 probability of me giving you a movie day, that means it will never happen. But if I said there is a probability of 1, that means it is certain to happen. So that means it would happen. If you get something in between, then the closer it is to 1 is the more likely, and the closer it is to 0, that's less likely. And if it's right in the middle, you have a 50-50 shot or an equally likely chance of it happening. You have heard in the past probabilities given as maybe a percentage, like a 50% chance of something happening, but we don't ever write probability as a percentage unless the question specifically asks for it as a percentage, and it will say that. If it doesn't, then you leave it as either a decimal or a fraction. You should definitely leave it as a fraction if the decimal is not a nice decimal. And what I mean by that is that it goes on forever and there's no repeating digits in any way, shape, or form. Just leave it as a fraction. Okay, so before we begin our probability unit, you need to know some vocab words. The first 4 are listed up here and their definitions are right after them. The experiment is the process that occurs, so it's what you're doing. So for this particular, well, there isn't really a question, but there's a spinner over here. So the experiment would be spinning a spinner for this particular question. You have to have well-defined outcomes, which means you need to know what's on the spinner. I can't just say, hey, spin the spinner, and what's the probability of getting a 7 if you don't even know what's on the spinner. So you have to know what the possibilities are. Other types of experiments could be drawing a card out of a deck of cards. You'd have to know that it's, a standard 52 card deck, or if it's some special deck of cards that maybe have pictures of shapes on it or colors, different colors on them. But you have to know what the outcomes could be. Rolling a die, you'd have to know, is it a standard 6-side die, and so forth. The outcome is the result from a single trial of the experiment. So if I said spin this once, what's the probability of getting a 1? You would say 1 out of 5. So that would be my outcome. The event is usually what the probability question is asking. It is a collection of one or more outcomes. So for example, an event could be for that spinner is what's the probability of spinning an odd number. Okay, so that is your event. The event is spinning an odd, spinning and landing on an odd. You could land on, they could ask you about evens, they could ask you about a number less than 3 or something like that. Land on odd number. So that is an example of an event. By the way, to answer that, you would count up how many actually are odd. So you have a chance of spinning a 1, a 3, or a 5. That's 3 sections out of 5 total. So that would be the actual answer. Sample space is usually denoted by an S, or sometimes I've seen 2 S's. But to list a sample space, you have to put basically all the outcomes inside the squiggly bracket. So what could you possibly get in that experiment? Well, for this particular one, I could get a 1, I could get a 2, I could get a 3, I could get a 4, or I could get a 5. And that's only with a single spin. If they added more to that question, like you're spinning it twice or 3 times, then your outcomes, your sample space, would actually consist of 3 numbers together as one outcome. So like you could get a 1 and then 1 and then 1, or a 1, a 2, and a 3, or something like that. So I already kind of did an example of how to find the probability of something, but here's the formal definition. It is always a ratio or a fraction, and on top is the number of outcomes that fall into that specific event. So for example, up here, I talked about landing on an odd number. So that's why I counted up how many odd numbers there were in my event or my experiment. And then on the bottom is always the total number of outcomes in the sample space. So you do have to figure out how many total possibilities there are in general. So like drawing a deck out of a standard deck of cards, or drawing a card, sorry, there's 52 cards, so the bottom would be out of 52 as long as you were actually drawing out of the entire deck. If you were only drawing, I don't know, let's say you only had 20 cards and you didn't have the whole deck, then you'd only be drawing out of 20, so your bottom number would be out of 20. So now let's talk about two more vocab words. You have theoretical and empirical. Theoretical, you've probably heard the word theory before. Like in theory, it's what should happen. It's not necessarily what will happen or what does happen, but it's what should happen. Empirical is what actually did happen. So to come up with your probabilities, we're going to be tossing 3 coins for this particular example. You may want to make a tree diagram to help you visualize what's happening. So here I am, start of the tree diagram, and I'm going to toss a coin, like a quarter. Okay, so I have a chance of getting a heads or a tail. This first row represents my first toss, correct? Yes. But then I'm going to toss it again. Well, let's say I got a head. I could then get another head or a tail. Or what if I got a tail the first time? On my second toss, I could still get a head or a tail. So this row represents the second toss. On the third toss, I have to toss it one more time. Off of each of those, I could have also gotten a head or a tail. So I have head or tail off of each of those. So this row represents the third toss. So we are now going to figure out our sample space by traveling down each branch. So here I am at the beginning. I could have gotten a head, or a head. That's one outcome. Then I could have had a head, or a tail. That's the second outcome. Then a head, tail, head. That's the third. Head, tail, tail. That's the fourth. So right now, if I got a head the first toss, I have a possibility of 4 different outcomes. Let's say I got a tail. I'm going to have another 4 outcomes. So that's 5, 6, 7. There are 8 outcomes total. So on the probability of all of my theoreticals are going to be out of 8. So what's the probability that I got all heads? Well, how many times did that occur in my tree diagram? Only one time. I only see one path that I could take that would give me all heads. So that is 1 out of 8. The probability of getting exactly 2 heads, we got to figure out how many times did that occur. Here's 1 time, exactly 2, which means I can't have 3. So I have head, head, tail, so there's 1 time. Head, tail, head, there's another time. And then there's 1 more over here because I could have tails and then 2 heads. So there are 3 out of 8. And then all heads or all tails. Well, or means it could be one or the other. Well, if I had all heads, that's one way. All tails, that's another way. So that's 2 out of 8, which does reduce to 1/4. Now, empirical is, hey, here's what happened. What was the probability? Well, probability all heads, that was a big fat 0. That did not happen for that one. Probability exactly 2 heads. I did have 2 heads, so that was certain to happen. It was a probability of, it's a 100% chance, which is a probability of 1. All heads or all tails, that's 0. That did not happen. So that is it for lesson 1. Let's move on to lesson 2 now. It's very short. Lesson 2 talks about set definition. So we actually are missing a part here. We're going to have to add that at the bottom. But a set is simply a collection of things, which are numbers, objects, etc., that satisfy a well-defined criteria. So they will tell you the criteria that you need in order to satisfy being in that set. The things that are contained in the set are called the elements. So here's our one and only example. We are talking about a set and we call it A. It's usually called named by a capital letter, an uppercase letter. It is defined as the collection of all integers. Remember, integers are on a number line, and they have to be greater than 0 or less than 10. So in roster form, you put them in these squiggly brackets, and you just list out, it's kind of like your sample set or your sample space, all the numbers that are in that set. So we can't be equal to 0 or 10. We have to be in between them, and we have to be integers. So we can have 1, 2, 3, 4, 5, 6, 7, 8, or 9. The Venn diagram, you guys know Venn diagrams are where you draw circles, and if the circles overlap, that means they're in both sets. Well, we only have one set in this particular example, so it's simply one circle, and all of those integers 1 through 9 are in there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now there is something that is called a subset, and it's not in your notes, but we're going to add it on there. A subset is any set whose elements are all contained within another set. So they wanted, if we took this particular set and asked an example. So for example, if I asked you to come up with a subset that is within this set. So write this down. Subset is a set of numbers within a set. Set of numbers within the set that you were working with. So let's say we said a subset of this could be all integers greater than 3. So it has to be within A, so I can't look at every integer in the world that's greater than 3 because I have to be within set A. So the only ones that are greater than 3 within set A would be 4, 5, 6, 7, 8, and 9. So that would be a subset of set A. And usually they also have you name it using another uppercase letter, and we'll call it B. So B would be a subset of A that is all integers greater than 3. They could also ask you to do like all the even integers within set A, so you would just list out 2, 4, 6, and 8, and so forth. So subsets are like smaller sets that are within the set that you originally were working with. So it's not out of like every integer or whatever you're talking about. So that is it for lesson 2, which is the end of this video.